everybody. Reporting to you again from the Glamour City, Hollywood.
And the other thing we needed to do was kind of look past what the goal has traditionally been for packing boxes. And it was always, what's the smallest box? Which makes sense, right? But we actually found that there's a difference between finding an optimal solution based on cost and waste versus just making everything smaller, particularly in multi-item shipments, where how do you decide if this should all be put in one big box or split out into three? And labor cost changes that, material cost, even really complex incentives kind of baked into your FedEx or UPS rate table affect that decision. So we, in order to make this, kind of any improvement over the prior kind of level of technology, we had to go extremely deep on what's otherwise a fairly niche problem.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for our show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by James Malley, CEO and co-founder of Paccurate. Welcome to the show today.
Thanks, Scott. Excited to be here.
So, James, I think at some point you went to theater school. Is that right?
I did. Yeah, that was my first love was theater acting.
And were you hoping to go into that professionally, and what capacity?
Well, I certainly thought so. I went to high school in a small town and, was very involved in theater. And there may have been a little bit of a big fish, small pond kind of syndrome going on there. And I thought I was destined for Broadway or Hollywood. And so, yeah, I went to theater school for college. Thankfully had the opportunity to minor in computer science, just in case that whole acting thing didn't work out. And by the time I graduated, I kind of realized that I enjoyed, I was making websites for theater companies in New York for beer money, basically. And I kind of realized I enjoyed that work a whole lot more, which, the moment I had that realization, I knew, acting was not going to be in the cards for me.
Well, that's a great story. I mean, who wouldn't choose beer, right? But I think there's also some takeaways in the sense that theater, I would imagine, taught you to not only present yourself in a certain way, but ultimately you are the medium by which you tell stories. And storytelling is incredibly important. And I think in many ways, when it comes to technology, we're just not very good at it, are we?
Absolutely. I mean, I definitely look back fondly at that time in my life because it was really, you get thrown into a kind of relatively high stakes kind of feeling environment where you're dealing with these really strong personalities and you're all supposed to come together and make something. And it was hard. It was really hard, but not that different from having a startup where you're growing really quickly, you're adding new people, you're making mistakes. And in the end, you're trying to tell a story to customers to kind of explain what it is that you do and why they should care about it. So I don't have to kind of reach very far, or I don't have to strain the metaphor to draw a line between art, that kind of art and technology startup.
Well, again, I just want to be very careful about how do I delineate this, but I think I could think of 2 prominent stories of tech founders who have really been very good storytellers, and in some cases legitimate, some cases not so legitimate. Right. Theranos, as we know, was a great storyteller, but it wasn't accurate, nor was it legitimate. The founder of WeWork, I think, we heard lots of interesting stories, including doing shots on top of tables, but ultimately it was theater, wasn't it? And it was theater that actually really inflated their valuation, if I may say so.
Right.
So storytelling, I think, is somehow represented, but in fact, when we look at the big successes, story is some of the key components. So coming back to that context, when we think about supply chain, what's the story? And why is it that we should care about, how we box things up?
Yeah. Well, to your point, I guess you could call it black hat and white hat storytelling. The way that we think about it is we're so close to the data. And for context, we have an engine that basically tells companies that ship things how to most efficiently pack them into the boxes they're going to be shipped in. But a lot of the data that we're immersed in and kind of the metrics and all this stuff, because we're so close to it, it means a lot to us when we are able to uncover some counterintuitive way of packing, or found another carton size that they should add to their fulfillment warehouse. Making that actually mean something to our champion at these companies, that's really the storytelling. It's not meant to kind of inflate or obscure what we're doing on the product side. It's more make this make sense to me in the clearest terms in the shortest period of time possible.
Absolutely. So let me formally introduce Paccurate in terms of what is sitting around optimizing packaging and shipping. So let's start with first definition. What is cartonization?
Cartonization. It's a clunky word that you won't find in the dictionary, but it's actually not a new concept. It's been around for around 30 years. Typically, a warehouse management system software, that run all these warehouses that are packing up your things that you order online. They have a system like this, and they have a feature called a cartonization module or something. And what it's meant to do is just to try to find the most cost-efficient way of packing up a shipment and display instructions of some kind. When we kind of got into the space, it was after years of kind of freelancing for logistics tech software providers. And so we had these relationships with shippers, like retailers, mostly e-commerce. And that was around the time that FedEx and UPS and the other carriers started really penalizing poor packing more. And so it sort of exposed the fact that this old concept of cartonization just wasn't cutting it anymore, because the pain had become a lot more acute. And so that's sort of why we started the company.
Yeah, that's a really interesting point. And I think the penalization, it was a critical feedback to the market mechanism. And certainly all of us, I think at one point have experienced some sort of boxes that we received, and you open it, it's a big box, but then it's a small little item, and then mostly just paper or air, fillers that is inside this box that's completely wasted. But at the same time, other people are thinking, well, didn't companies like IKEA have already figured this out decades ago? Why aren't companies doing this, and why are they not doing it well?
Yeah, well, it turns out it's kind of a hard problem to solve. It's a relatively deep problem, both kind of mathematically, but also operationally. IKEA is amazing in that they've, the flat pack method, where they design their products in such a way that they will be sustainable to ship, both from an economic and environmental standpoint. But most e-commerce shippers can't do that. They can't affect, the design of the product and make sure that out of the box, so to speak, it's ready to ship efficiently. Usually, if you're going to Amazon or you're going to any other retailer, you're probably going to pick up a few different items, and understanding in real time how those items could be packed up efficiently is it's tough. Humans are not really good at it. And we can attest to this because we look at packing solutions for shipments all day long, and we'll see one and we'll be like, wow, that one's great. It must be like 90% cubic utilization. They really fit that perfectly in the box because we're nerds and we do that. And then we look at the math and we're like, wait a second, this is only 70% cubic utilization. The rest was air. So humans are just really not good at it. We're not good at looking at three-dimensional space and understanding exactly what we're looking at.
Yeah. So let's talk more concretely. So when we think about awkward things, and I think your website mentions like a pick shovel or axe, or really kind of obtuse, strange objects that doesn't quite fit that rectangular type of shapes. How do you take something like that and then look across item dimensions, box dimensions, and some of the rules and constraints to come up with that optimization? I wonder if you could tell us a little bit more about that, as well as the math behind it in terms of the volumetric comparison, the 3D simulation.
Sure. So our engine is kind of in the family of, or the problem we solve is kind of in the family of problems called the bin packing problem. So you can, if you're interested in that problem set, you can consult any number of MIT thesis papers or even Air Force papers that go into detail. But basically, it's how do you quickly figure out how best some three-dimensional object can fit inside another three-dimensional object. Where we had to hit a couple milestones for ours to actually be a significant improvement over prior solutions. One was we have to make sure we can flexibly accommodate any use case, any edge case that may come along. So it's not enough just to say, okay, this item is fragile, so it needs bubble wrap. That you can't just featureize that as fragility. One of our customers, Crate and Barrel, they have all kinds of definition of what fragile means. I mean, it's different for a cup versus a plate, So we needed to make sure that we had the flexibility to accommodate all, item constraints and characteristics that you couldn't really do with prior solutions. And the other thing we needed to do was kind of look past what the goal has traditionally been for packing boxes. And it was always, what's the smallest box? Which makes sense, right? But we actually found that there's a difference between finding an optimal solution based on cost and waste versus just making everything smaller, particularly in multi-item shipments, where how do you decide if this should all be put in one big box or split out into three? And labor cost changes that, material cost, even really complex incentives kind of baked into your FedEx or UPS rate table affect that decision. So we, in order to make this, kind of any improvement over the prior kind of level of technology, we had to go extremely deep on what's otherwise a fairly niche problem.
As I'm listening, I'm fascinated, and of course, ultimately, at the end of the day, it's an optimization problem or minimization, constraint function.
Right.
But in addition to this 3D cube logic that you're referring to, you're talking about some of these complexities of business rules and item requirements, and I'm thinking about the fragility aspects where it's really getting to modeling physics around how much pressure can it take before it starts to crack, as an example, to looking at the carrier tables on a real-time basis. So there's a lot. So talk about both the kind of the real-time feeds as well as the tuning and configuration that's required for each of the companies and some of the product SKUs, and how extensive is this before they can get it up and running?
Yeah, we find on average, every shipper has like one edge case that we have to sit with them and explain how they could account for it in the API request. So Paccurate is a stateless API. So all of the configuration goes into the request, and everything you need to know about the shipment comes back in the response. So there's no configuration on our side. We never want to be the system of record. We just want to be the math guys. So we get called from, as I mentioned, WMS systems, but even increasingly from online shopping carts as free shipping kind of goes away. People want to be able to offer actual shipping quotes that are based on something real instead of just a random guess. And so that's been kind of an interesting development.
Interesting. That is very interesting. Tell us about some metrics in terms of how your solution is helping manufacturers, distributors, carriers, retailers. What are we talking about in terms of savings as well as the carbon reduction?
Sure. So we find a minimum savings on transportation of around 6%. And that kind of has to do with whether they're coming from a full 3D, like advanced, system from the previous generation, and then incorporating the costs that I just mentioned. 6% tends to be the average. In general, though, I mean, most shippers don't have anything that advanced. They have either just tribal knowledge. There's like a guy in the warehouse that's responsible for choosing boxes, or there's a liquid fill cartonization, which is just saying this object has a lower total volume, therefore it should fit in this box. It's not 3D, it's just like basic comparison. So that's typically what we tend to replace. And it's super fast because, we made that choice to make it stateless. We can do, hundreds of requests per second, and it takes around 2 milliseconds per item in the shipment to return a packing instructions with a 3D visual.
Amazing. And I think if I didn't misread it, I think there's a opportunity to reduce trailers required for the number of shipments. I think reduction was at 14% less.
Yeah, that's kind of held strong since we first sort of figured that out. We needed kind of big customers to come in so we could get big, juicy data sets to really confirm a lot of that. But 14% is the average, because these trailers are floor loaded. So it ends up being almost like a liquid, where if you reduce the size of the cartons by 14%, over time, you're going to reduce the number of trailers you're going to need. So, one of our large customers, that resulted in 400 fewer trailers required at their DC, which was pretty exciting when we figured that out.
Absolutely. Now, help us understand, because there's a lot of complexities that I'm sure our listeners don't know unless they're in this particular space, is that they're probably thinking, well, once they figure out the optimal package and shipping, do they still need your software on an ongoing basis, your stateless APIs? Wouldn't they have already figured it out? Or talk about the dynamic aspects of how it changes with every shipment.
Sure. I mean, particularly e-commerce, where there's a mix of items, things are going to change over time. It's rare that you're shipping, unless you're, maybe a hot young D2C brand with a flagship product and you don't really ship much else. Almost every shipment is different, because if maybe it's the same items, but if it's to a different location, then the carrier kind of incentives are different there. So you may be splitting that shipment up into multiple boxes instead of putting it in one big one, depending on the scenario. So particularly in e-com, there's not really such a thing as let's just figure out this math once and move on. There's just too much variability. You kind of need it ongoing.
Mm-hmm. Now, let's talk about Amazon again. I recognize that you're working with carriers and distributors and manufacturers, but in the case of Amazon, wouldn't they already do this themselves, or why would they not just simply acquire you guys or create this technology on their own?
Hey, Amazon, you heard it from Scott first. No, we get this question about Amazon a lot, and part of my answer is speculative, but it's also informed by what they publish publicly on science.amazon.com, I believe it is. They're really fascinating papers on some of this problem. So we do have some insight into how they think about it. They are unique, and not just for their size, but because they control so much of their supply chain, and speed is, down to the millisecond is really what they optimize for. So at the moment, they don't have to care about cubic utilization. And I think they're doing better than they have in previous years. But I've kind of been wondering, honestly, when Scope 3 emissions reporting requirements come down, what that's going to look like when they have to put their numbers out there. Because I understand there's good reasons for things to show up, tiny things that I order to show up in huge boxes. But it's still kind of upsetting when you think about the vast economies of scale we're talking about. Unneeded truck trips, millions of square feet of corrugate, I'm sure. So it'll be interesting if they adapt to that and put more emphasis on cubic utilization, or if they're just going to say, hey, you come to Amazon because you want something now, not because you're willing to wait an extra day.
Interesting. So which brings us to the topic of future of shipping. And I wonder if we could explore different things from more local factories and local manufacturing to even drone deliveries. So while maybe the average weight might be 5-10 pounds, the fact that you want to, try to package more so that you're having to make less drone deliveries, for instance.
Yeah.
So tell us about what do you anticipate and how that's going to potentially either increase the demand for your software, or maybe not.
Yeah, we're kind of like the the boring ones at the party that everybody's like, okay, all right, great, I'm glad you're here, and we want to talk about like square inches of cardboard saved and what that means in emissions. I'm very excited for a lot of the technological developments, both in terms of drones, but even just kind of inside the four walls of the warehouse. There's some really cool things with robotics and AR and sensor technology. We kind of see ourselves as possibly part of the plumbing for all of those innovations, because we deal with really a foundational issue of how does this fit in this other thing, particularly for drones, where space is obviously going unless there's a massive leap forward in the size of drones, and honestly that might be a little terrifying. Really the cubic volume capacity of a fleet of drones, it's much more critical to make sure everything fits together. And even in the warehouse, we have robotics companies coming to us and saying, we know hardware. Will you figure out this side of it so we don't have to think about it and just make sure we're using the least amount of space possible?
Very interesting indeed. And of course, when we think about certain verticals, let's say, for example, prefab or pre-built housing, and housing continues to be a real issue around the world. And of course, I think Tesla has an extension of a business that has basically kind of a boxable type of a modular building. How can your solution help with some of these other types of industries where packaging may be large types of things and transporting it is very costly, and any way that you can help save them money as well as the need for those trailers would be significant?
Yeah, I mean, we mostly position ourselves as parcel experts, but a lot of our customers have used our technology for pallets and for trailers, containers, and just because they were using it for these various modes, doesn't mean you couldn't use it for something else where there's kind of a 3D consideration with the complexity of sort of external cost factors. As an example, we offer up our API for free to hackathons, because it's really fun seeing what the students or participants come up with. And I know one of the recent ones we did, somebody figured out how to use it to build vertical grow house plans based on all this external data. I mean,
interesting, very interesting.
It's flexible enough where you could kind of use it for anything related to that.
So at the time of this recording, we have something really historical, which is the Artemis 1, after many months of delays, has finally taken off, and the Orion is currently en route to Moon. It's going to take about 25 days or so. And the reason I bring this up is not just simply in terms of rockets and SpaceX and others that are delivering payloads up into low orbit, middle, or even higher orbits, but ultimately, as we get into further Artemis 2, 3, and subsequent, essentially setting up shop, so to speak, on the Moon and eventually Mars, we're going to have to start sending components. I mean, that's the reality. We're not at a point where we can completely mine things as much as we want to in situ resources. We need to bring pieces so that if some of it's for habitat, some of it's for space agriculture. And of course, as we know, there's probably nothing more expensive than sending things from Earth to outer space. Tell us how Paccurate could be helpful in endeavors as it relates to not only NASA, but even private space stations and hotels in space.
Wow. I can't say that we have, thought about like a cohesive go-to-market for space usage, but without violating scary NDAs, I can say some aerospace organizations have approached us and conversations have been ongoing about, more of what you would think of as like the small stuff. Like, how do we make sure this container is as small as it possibly can be? We're not really in the business of rocket loading although I welcome any any company that does that to reach out. But yeah, super interesting you brought that up though.
Terrific. Any final comments as well as where you guys are as a company and what's next for Paccurate?
Yeah, I think, as a parting note, we were kind of interested in this problem set when we started and really became obsessed with it once we realized the sustainability angle. When we were able to start measuring square feet or cardboard in acres actually for some of our larger customers, and understanding how this could be an ESG kind of win on top of an efficiency win. That's when we kind of knew that we had to dedicate our at least a portion of our adult lives to bringing this to market, and it's just been incredibly fun. And so in terms of where we are, we raised a seed round at the beginning of this year, built out the team mostly on the engineering side, and just recently released a analysis product on top of our core API that people can just come in, upload shipping data in spreadsheet form, and say, okay, what would my last 3 months of shipping have looked like if I had changed this one small thing? If my widget were a quarter of an inch smaller, or what cartons should I use in my stores for shipping? Anyway, so there's a lot of work to do. There's a lot more value we think we can add, and a lot of waste we think we can remove from supply chain.
Well, I think your past as an actor and storytelling came full circle as it pertains to ESG and sustainability for Paccurate. I have been joined by James Malley, who is the CEO of Paccurate. And thanks for joining today.
Thanks, Scott.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.